Good afternoon. Thanks for joining us across the fence. I'm Fran Stoddard. The farm of today holds a wealth of data. Every crop that's cut or cow that's milked is a piece of information that tells a bigger story. Farmers use these data points to determine the efficiency of their operation and where to make improvements. Across the Fence recently rode in a tractor tricked out with state-of-the-art gear that's helping farmers solve a math problem about nutrients, natural resources, and environmental protection. Keith Silva has our story.
From the cab of his tractor, Eric Severy is master of all he surveys. And once the GPS coordinates are set, he doesn't even have to hold the wheel.
We use this screen here.
Severy is a custom operator. His business, Matthews Trucking, contracts with farmers to spread manure based on the farmer's nutrient management plan. Each plan details the amount of nutrients to be applied. Plans are required by state and federal law.
Yes.
For the last several years, Severy and UVM Extension agronomy specialist Kirsten Workman have been using the Barnes Farm in Bridport to trial, test, and troubleshoot manure injection technology. Instead of being sprayed on top, manure is injected under the surface where it's needed. Doing so limits erosion and runoff getting into waterways. The latest tool Workman and Severy are assessing is this yellow box that looks like it could contain a new pair of barn boots.
Manure sense constituent is the technical term for it. It's an infrared sensor that tells us what nutrients are in the manure as we're pumping. It samples it 4,000 times a second. So per 1,000 gallons that is flowing through that pipe, how many pounds of phosphorus are in that manure, how much nitrogen, dry matter, and potassium is in that manure, and then through the flow meter and the speed of the tractor, it is telling us what we're applying at a certain point.
Not all manure is created equal. Because nutrient management plans are written with the previous year's data, there's no way to account for seasonal changes, like the weather. That's where the manure sensing technology comes in.
Manure values greatly vary, more than a nutrient management plan accounts for. So I believe there are times we are over applying, and also times we are under applying the amount of nutrients. The amount of gallons we're applying coordinates with the nutrient management plan, but the actual nutrients are not. We're trying to test to see how much the manure really changes and whether we can vary our rates to grow a better crop for the farmer.
UVM Extension holds workshops to help farmers write nutrient management plans. No plan is flawless, but Workman and her colleagues come as close to perfect as possible.
So right now the way it works is a farm has a nutrient management plan. And that is a giant math problem that we do the best job that we can. So this farm has a nutrient management planner. They're sampling manure every time they spread, essentially. And that one jar of manure is hopefully capturing the nutrient content of millions of gallons, right? So we're already starting to average. Now we take years and years of those manure samples and kind of come up with a farm average. So we get a little more accurate, right? Because from year to year there's variation.
The sensing technology takes the guesswork out of the amount of nutrient content being applied and provides more accurate data for next year.
If we're really using actual nutrient content in the moment, then we start applying in pounds of phosphate per acre instead of gallons per acre. And the difference that can make can be really big and it can be really small. We don't know yet. And that's what we're going to look at here is we're going to take the information from Eric's manure sensor and the farm's nutrient management plan, and we're going to reconcile those two. As we feed more and more precise information into that plan, the more precise it gets every year moving forward.
A big part of it for me is the record keeping. Now I have a digital record of exactly what went on this field. I can print a map off, give it to the state, give it to the farmer. I feel we're on the cutting edge of that stuff. We were one of the first people really fully integrating GPS in the state. It's really just kind of cool.
The manure injector and the manure sensor were paid for by grants from the Vermont Agency of Agriculture, Food and Markets. As wondrous as this technology is, it's also a justification of the investment and the work being done by UVM Extension and farmers to protect the environment.
Practices and technologies like this that have a benefit to the farm and a benefit to the environment, it's a no-brainer for everybody. And the state really has to justify how it's spending its money too, which makes sense. And so when we can quantify those impacts, then that helps the state make the case to the EPA, our farmers are doing X, Y, and Z. It really has enabled them to pay for practices and technologies, but also then justify those back to the folks that are paying really close attention. Farmers are hitting it out of the park, and it's a huge teamwork kind of effort.
On the ground, or a couple inches below, it's good to have a sense Vermont farmers are doing their part to preserve natural resources. In Bridport, I'm Keith Silva with Across the Fence.
We'll stay on the topic of problem solving for our next story. UVM Extension's agricultural engineering team works with farmers to find low-cost, high-impact solutions to improve food safety on small farms. When farmers need a way to clean salad greens to keep their businesses above water, the Ag Engineering team got to work and found a new spin for a common household appliance. Taylor Mendel of Footprint Farm in Starksboro tells us how.
Our farm is called Footprint Farm. It's very small. We grow on about 1.5 acres outside, and we have about 1/4 acre inside in high tunnels. We sell primarily to a CSA with about 80 members most of the year. We also go to the Shelburne Farmers Market and sell to a number of local restaurants and caterers. This behind me is our greens washing line. A greens washing line is where we wash mostly triple washed greens, which are things like salad mix, arugula. We do something called a zesty mix. It is somewhere where we come in through that big door behind me. That's where all of our dirty produce comes in. And then it goes through each bin of clean water, gets drained in the orange baskets, goes into the spinner here, and then gets packed for delivery. Something that's really important for us as a business is to have a product that's very high quality and that lasts longer in the refrigerator than something that somebody could get from the grocery store. A big piece to that is having really clean, really dry leaves once it goes into storage. So we used to use this hand crank restaurant style spinner, and it takes a long time, it's exhausting, and we just couldn't get through very many greens at a time. So we upgraded to a washing machine spinner so that we could set it and forget it, let it spin dry. We were getting super clean, super dry greens that we've gotten up to a month of storage life in the refrigerator.
A washing machine?
Yeah, we are a small farm, so we don't have the space or the resources to get the machines that the bigger farms use. So there are a lot of really great resources for farm hack machinery that we can use on our scale. So what people will do is they'll get a used or more and more new washing machines. They deconstruct it, take away the pieces that don't make sense, and put a switch timer on it so that you can put the greens inside and put it on the spin cycle. So we're not doing the agitate cycle, and you get a really nice dry product. The Maytag was great for a while. It's very loud, which doesn't seem like a big deal, but when you're in here washing greens hour after hour, and you get to the point where you need to wear noise-canceling headphones, it makes it less enjoyable.
How have you worked with UVM Extension on this project?
As we got to talking, Andy said, well, what if I was working on a washing machine conversion project? Would you be willing to test it? And we, at the time, we're having a huge issue with our current spinner, and we said, yeah, obviously we'd love to try it, and here we are.
Washing machine spinners are very common on the small farm, and it's really important because it fits the good in-between size of spinners, from the hand crank models to the industrial commercial spinners, which run multiple thousands of dollars. So this kind of fits in between there. It's not designed for produce, obviously, and there are a lot of extra parts you don't need. You don't need the agitator in there. You don't need all the fancy electronics. You don't even really need the housing on the outside on some models, and then taking that off allows airflow, so it's easier to clean and easier to dry out. A conversion with a timer and maybe a couple added bumpers, including buying a basket. The timers are like 30 bucks, the baskets are like 30 bucks, and then the rubber bumpers on the other model are like 15 or 20 bucks. So really it's between $50 and $100 for a conversion. $400 or $500 for a Maytag, and it gets up $900 to $1,000 for a Speed Queen.
The nice thing about the Speed Queen is that it's extremely quiet. You can have a normal conversation while it's running. So we can have 4 people in here doing lots of different things while the greens line is running, and it doesn't interrupt our workflow. It was like upgrading from a VW Volkswagen Bug with 3 wheels to a Corvette overnight. It was just completely different. UVM Extension is working on issues that are really important for small farms. I have friends who farm in other states, and none of them have the experience with their extension agents that we do. We can email UVM Extension at any time and get a response back relatively quickly with a whole list of resources, tons of links to other resources that they've collected, or if they don't know, they'll look into it oftentimes if it seems like it's something that would help others.
And that's our program for today. Once again, thank you for joining us across the fence. I'm Fran Stoddard. Stay well.